Welcome to this video on Kubernetes Endpoints. In this session, we'll explore how Kubernetes tracks pod IP addresses behind services. Endpoints are a fundamental component of Kubernetes networking that enables service discovery and load balancing. An endpoint object is a Kubernetes resource that automatically tracks the IP addresses and ports of pods matching a service selector. When you create a service with a selector, Kubernetes creates a corresponding endpoint object with the same name. This object maintains a dynamic list of all healthy pod IPs that should receive traffic for that service. The lifecycle of endpoints follows 4 steps. First, a service is created with a selector that defines which pods should receive traffic. Second, the endpoint controller, running in the control plane, continuously watches for pods matching that selector. Third, the controller automatically creates an endpoint object containing the IP addresses of all matching pods. Fourth, as pods are added, removed, or become unhealthy, the endpoint object updates dynamically to reflect the current state. The structure of an endpoint object is organized into subsets. Each subset contains 2 main sections, addresses and ports. The addresses section lists the IP addresses of all healthy pods, such as 10.244.1.5 and 10.244.2.8. The ports section specifies which port and protocol to use, such as port 8080 with TCP protocol. This structure allows kubeproxy to configure routing rules correctly. You can view endpoint objects in your cluster using the kubectl get endpoints command. This command displays all endpoint objects along with their associated pod IP addresses. Each endpoint has the same name as its corresponding service, making it easy to identify which pods are backing each service. This is useful for troubleshooting connectivity issues or verifying that pods are properly registered. There is a direct one-to-one relationship between services and endpoints. When you create a service, Kubernetes automatically creates an endpoint object with the exact same name. The service defines the stable entry point and selector criteria, while the endpoint object contains the actual pod IP addresses matching that selector. This separation allows the service to maintain a consistent interface even as the underlying pods change. While endpoints have served Kubernetes well, they have limitations. Traditional endpoint objects store all pod IPs in a single object, which is limited to 1,000 endpoints and causes performance issues at scale. EndpointSlices were introduced as a more scalable alternative. They split endpoints across multiple slice objects, provide better scalability, and are now the recommended approach for large clusters. However, understanding endpoints is still important as they remain widely used. Let's recap the key points. Endpoints are Kubernetes objects that track pod IP addresses behind services, enabling service discovery and load balancing. They are automatically updated by the endpoint controller whenever pods are added or removed. Each endpoint object has the same name as its associated service, creating a clear relationship. Finally, while endpoints work well for smaller deployments, endpoint slices are preferred for better scalability in larger clusters. Understanding endpoints is essential for troubleshooting Kubernetes networking issues.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.